So looking at the second half of lesson 5.2 on properties of rational exponents and radicals. This is where we're going to get into reviewing all these rational exponent properties. And we're going to look at a couple of properties of radicals as well. Right, so we have product of powers here as our first property. Right, if I have a base to an exponent times same base to an exponent, right, I'm going to add those exponents. So we see that example there where we added the exponents and then applied it to the base. Power of a power, a to the m and then to the n, we take that, we can simplify that as a to the m times n. We multiply those two exponents. Power of a product, so we have two numbers multiplied and then to an exponent, a times b, and then to the m power. We can say that is the same as a to the m times b to the m. Negative exponent property, right, means our term is on the wrong side of the fraction bar. Zero exponent, anything to zero power is equal to 1. And then quotient of powers, a to the m divided by a to the n is equal to a to the m minus n. We see this here, right? We subtract those exponents. And then power of a quotient, a divided by b, then to the m, is the same as a to the m divided by b to the m. A quick look at two rational powers. Product power of rationals, product power of rationals, of radicals, right? If I have the nth root of a times b, that is going to be the same as the nth root of a times the nth root of b. Very similar to our power of a power property and our power of a product property for rationals, but this is for radicals where we have that radical, that root sign. And then we have the quotient property, right? Quotient property of radicals. So if I have the nth root of a over b, that is the same as the nth root of a over the nth root of b. So those are some properties that are going to help us out with our lesson today. So using properties of exponents, right, I have 7 to the 1/3 times 7 to the 1/3. That is going to be the product of powers. So that is going to be the same then as 7. And I'm going to add those two exponents, right? So that's going to be the same as 7 to the 2/3. And then if you needed to, you could evaluate that out with your calculator. For example, b, 3 to the 1/4 times 3 to the 1/2, then all squared. Well, I'm going to use the product of powers on this part inside, right? Because I have this base of 3 for both, so I'm going to add those exponents. So 1/4 plus 1/2, that's 3 to the 3/4 then, and then squared. Now I am going to use the power of a power property, right? Because I have two exponents here, which means I am going to multiply those exponents. Well, 3 times 2 is 6 over 4. If I reduce that fraction, then the 6/4 becomes 3/2. Again, I could use my calculator to simplify that expression if I needed to. For C, 4 to the 5th times 3 to the 5th, then all to the 1/2, or to the negative 1/5, sorry. So I am going to work that out. I know that this tells me it's all on the wrong side of the fraction bar, right? This negative. So I'm going to move this all below the fraction bar. So the 4 to the 5th times 3 to the 5th, and then all to the 1/5. Okay? Now I can use the power of a power property, and I can take each of these terms and multiply them by 1/5. Well, 5 to the 1/5 is just 1, right? So this 4 to the 5th times, and then to the 1/5 is just going to be 4, right? Let's look at that. 4 to the 5th, and then to the 1/5, right? 5 times 1/5 is 1, right? So this is just going to be 4 to the 1, and then that 3 to the 5th to the 1/5 is going to just be 3. So this 4 times 3 is 12. Part D, we have a lot going on. My first thing that I would do is simplify these coefficients out front, the 8 and the 32. Well, they're both divisible by 8, right? 8 divided by 8 is 1, and 32 divided by 8 is 4. So that cleans up that part. And now I would go through and I would work on getting rid of any negative exponents, right? So this term right here, this a to the negative 4th, that is on the wrong side of the fraction bar. So that needs to be an a to the 4th up top. But we already have an a to the 6th. So a to the 6th times a to the 4th is going to be a to the 10th, because we would add those exponents. Same would go here for b to the negative 4. That is on the wrong side of the fraction bar. So that needs to be moved down below and combined with the b to the 5th to make b to the 9th. And then finally, the c term, I have c to the 8 over c to the 9. So I'm going to subtract those. 8 minus 9 is negative 1, meaning that c belongs below the fraction bar. You can also think of it as kind of canceling out. These 8 up here cancel out 8 of the 9 down below the fraction bar, leaving just 1 down below. Looking at example 2, properties of radicals to simplify each expression. So I have the third root of 12 times the third root of 18. So I can combine these all under one radical. So I want the third root of 12 times 18. So that's going to be the third root of 216. If I calculator that up, right, the third root of 216 is 6. For part B, I have the fourth root of 80 divided by the fourth root of 5, right? That's going to be that quotient property of radicals, right? I can combine the 80 over 5 under 1/4 root. I know that 80 divided by 5 is 16, right? That's calculator work if it needs to be. So I have the fourth root of 16, which would be 2. Again, calculator work if you need it to be. For part C, we're taking the cubic root, the third root of each of these three terms underneath. So I want to do the third root of 8. Well, the third root of 8 is 2. And then I'm going to do the third root of a to the 6th. So I am going to divide that 6 by 3, right? I'm going to take the exponent, divide it by this n value of 3. That is 2 remainder 0, right? So it's going to be a squared on the outside with nothing carrying over under the third root. And then for b to the 14th, b to the 14th, the third root of that. Well, I'm going to take the 14 and I'm going to divide it by 3. 14 divided by 3 is going to be 4 remainder 2. So that is going to be b to the 4th square root, or third root, sorry, of b squared. Right? This 4 is my exponent on the outside. This 2 is my exponent on the inside. Now, for part B, looks pretty intimidating. We have the 5th root of d plus 12 to the 17th power. So all I'm asking you to do is apply the properties with these exponents, right? So you're going to take 17 over 5, right? 17 divided by 5 is 3, remainder 2. So you are going to have d plus 12 to the 3rd, right, from this number here on the outside, and then the 5th root of d plus 12 squared from this number on the inside. I am not asking you to simplify out, to multiply out the d plus 12 to the 3rd. So 3 more. I have 5 square roots of y plus 6 square roots of y. Because they're both square root of y, I can add those coefficients out front, right? 5 plus 6 is 11 square roots of y. For part B, I have 12 times the third root of 2z to the 5th minus z times third root of 54z squared. So what I need to do is simplify these radicals. So to do that, I am going to say, well, the 12 is going to stay, and the cubic root of the 2 is going to stay. But I need to take this cubic root of z to the 5th. Well, 5 divided by 3 is 1 remainder 2, so that's going to be z and then z squared underneath that cubic root. Right? Because 5 over 3 is 1 remainder 2. So I'm going to have a z here and a z squared underneath. And I think on your notes, these are m's. I changed those to make it so they're not z's. My z's and 2's look a lot the same. And then I'm going to work here on this part, right? What is the third root of 54? Well, I can factor 54 into 3 times 3 times 3 times 2, right? So a third root here is going to be 3 cubic root of 2. And then that z squared is going to stay underneath. So this 3 times this z is 3z cubic root of 2z squared. What I have done is I've worked hard and probably not explained super well, but I have gotten common terms under the radical, right? They're both cubic root of 2z squared. So I have 12z minus 3z, which would be 9z, and then the cubic root part matches. That's what allows me to do that subtraction. For c, I have the fourth root of x to the fourth over y to the eighth. So what I am really going to do here is I am going to take the fourth root of each part, the numerator and the denominator, and that allows me to simplify, right? The fourth root of x to the fourth is x, and the fourth root of y to the eighth would be y squared. Right, I'm going to divide those exponents by the n value on my radical. So just lots of applying properties here. Make sure you are looking at your notes and reviewing those properties at the beginning.